All right, so today I just wanted to make a video to help you all on the second written practice, specifically questions 4 and 5, because they're covering some material that might seem a little more challenging than what we talk about in class, or even just completely not obviously related, although hopefully you'll see the connections by the end of it. Okay, so on problem 4, the setup is there is some data, and the data that they give us, although I'm going to use different ones, they have the 0, 0 points. This is x and y values, 224, 4 and 384, and then 6 and 1944. So this data is growing very fast. Okay, it grows fast. And when that happens in real life, to get a handle on fast-growing data, we'll often just take the log of both the x and y value to see if some other relationship pops up. And so this is an example of what we might see. So the pretense is there is some relationship that is unknown, but in fact, this is the real relationship in the background, which is y is equal to some constant times x to a power. And when that power is big, this data is really hard to see. So if we pop over here to the Desmos window that I have, you can see that the function that I'm looking at is when my constant is e, and then my power is 2. So I have ex squared. And even then, when I start to plot my data, oh, in fact, let me back up and show you how to make one of these tables, because that's something you'll probably have to do. So that little plus sign in the upper left, and then hit table. And now, well, here, let me just show you what our current data for this problem looks like, and then we'll go to something else. So we have 24, we have 4 and 384, and we have 6, and we have 1944. So very quickly, this data goes way off the window, and in order to get it, we need to be up around 2000, and it's just so hard to tell, right? Like I can kind of resize it, and there we can start to see some curvature to it. And you can see that my x window is only going from like 0 to 10, but my y window goes from 0 to 2000. But anyway, from the home screen, you'll only really see one data point, and you'll have to move around to get the others. All right, so let me run through with some other numbers. So if I want to create a table again, let's go ahead and make that table. And I'm going to reference this background function. And the way I'm going to do it is 1, and I'm just going to say, give me f of 1 for the y value. And now you can see it plotted that first point. 2, give me f of 2. Oops. And similarly, we'll just hop up to 4, and we'll do f of 4. And we'll do one more value. We'll say 6 and f of 6. Oh, I do want to demonstrate an issue with logs. So we'll start with 0 as well. So this is very similar to what's in the homework in that I use the same x values, but I do have a different function. Anyway, once it's plotted, again, it's already going out of the window, and I'd have to zoom out a lot in order to see all my data points. Okay, so there they are. Let's go back to the home screen. All right, now, if I want to make new data, where what I do is transform this data by just taking the natural log of what's in the x column and the natural log of what's in the y column. So there's one issue, which is right here on this first row. You're not allowed to take natural log of 0. Okay, so right off the bat, we're going to want to delete that entry. But otherwise, we'll have natural log 2 and the natural log of, well, okay, ooh, sorry. This is the data for your homework. So let me do the one I'm talking about. I'll use a big eraser. We have our x and y values, and in my case, y is equal to e times x squared. And so we can just say what a few of these values are. So 0 is going to go to 0, and then 2, well, 2 squared is 4, so this is going to go to 4e. And 4 squared is 16, so this will go to 16e. And 6 squared is 36, this will be 36e. Okay. Now, when I take the natural log of everything, then my first column is natural log of the x values, my second column is natural log of the y values, and I'm not going to use 0, so not 0. So let's remove that. Then we have natural log 2, gets paired with natural log of 4e, and then natural log of 4 gets paired with natural log of 16e. And finally, natural log 6 gets paired with the natural log of 36e. Okay, so let's go ahead and graph that data in Desmos. So here's what we would do. In the Desmos window, I can make a new list where my x2 value is equal to the natural log of the x1 value. And you can see Desmos says, oh, okay, it's a list with 4 elements. And if you're curious how I got the subscript, so the button you would normally hit for the minus sign, so just to the left of plus and just to the right of 0, hold down shift and hit it, and that'll pop you down to the subscript. So there we go. And if I were to continue, well, let me just, I'll continue. There is an error that I'm going to have to fix. And just to let you know what that error is, it's this 0 thing. So let's see what happens if we include 0, okay? So my y sub 2, let's get down there we go. Y sub 2 is equal to the natural log of y sub 1, right? And those are the names that Desmos gave my original data. So that's why I'm using x sub 1 and y sub 1. Okay, let me take away the original data and let's plot the new data. So the way I tell Desmos to do that is I say, hey, plot this list. So the x, oops, not x1, sorry. I want the x2 list for the x coordinates, and I want the y2 list for the y coordinates. And there's my new data. And in fact, if I hit home, it grows much more slowly. And in fact, these points look like they lie on a line, and that's because they do. So what line do they lie on? Well, first, let's do it algebraically, and I'll show you what's going on with natural log. So if, oops, let's get an actual pen. If y is equal to e to the x squared, then, all right, equals means equals. So I'm going to do the same thing to both sides. Natural log y is equal to natural log e times x squared. Okay, and now we want to use some rules of logarithms. So the first rule of logarithms that I have written out here says that the log of a product is the sum of the logs. So I can break down this product here, and I have natural log of e plus the natural log of x squared. Okay, so the whole reason I'm using e is because the natural log of e is just 1. So this is 1 plus. Okay, and now if we look at this second rule that I have written down, it says if you have an exponent on the inside of the log, you can actually just pop it down to be a coefficient. So this will become 2 natural log of x. And so now we have a new relationship between natural log of y, that list of numbers, and natural log of x, that list of numbers. And in fact, it's a linear relationship. I have an input variable, which gets multiplied by something, and I add something. So it looks like my input variable times a slope plus a y-intercept is equal to my output variable. Okay, this is the form that my new data has, that this data will take, the ln of x, ln of y data, right? Because ln of x, if you multiply it by 2 and add 1, you'll get ln of y. So that's just the relationship for going from left to right. Okay, so this is what we should expect. We should expect a line with slope 2 and y-intercept 1. So let's go ahead and plot that line. All right, so if I say y equals 2x plus 1, you notice it goes right through my data points. All right. Now, that was me doing this all by hand. Let me have Desmos find the line for me. And when Desmos tries to find the line for me, this is when the 0 error matters. So if I suspect, okay, my suspicion is that this y2 list is actually linear with respect to x2. So it looks like mx2 plus b. Okay, this is my guess. All right. I can have Desmos find the slope and the y-intercept. And here's how I do it. So I tell Desmos, hey, I believe y2 is related to x2 in the following way. It's equal to m sub x2 plus b. Okay? And if I tell Desmos this, and I hit enter, oh, it doesn't like it. Okay, and this is that 0 error. So now let me show you what happens if we take away the zeros. So I get rid of this, get rid of that. All right, and now suddenly something changed, right? So first off, I only have 3 element lists for x1 and x2. The 3 points that were plotted, those didn't change because it never plotted the 0 point because natural log of 0 is undefined. So it just never even shown it. But now, when I tell Desmos, hey, I believe y2 is related to x2 via this linear relationship. So I believe y2 is equal to mx2 plus b. And when you use that little tilde sign, what you're telling Desmos to do is find m and b. And that's what Desmos will do. And so we can see down here toward the bottom where it says parameters, and it says m equals 2, b equals 1, right? That's exactly what we found before, m equals 2, b equals 1, okay? As far as some other things, when it says statistics, little r squared equals 1, that's just saying that this blue line that they created fits our data perfectly. When r equals 1, that means there's no error, okay? All right, so let's see how this changes as I change my underlying function. So this is why I did function calls here, because for example, instead of using e, I could do something like 4, okay? And now my y-intercept, so if I had y was equal to 4x squared, then the natural log of y is equal to, I'm going to jump straight to this formula here. Okay, so it's the b, so 1.38629 plus 2 natural log of x. So these two numbers are the m and the b that Desmos gives me. And now let's work backwards. Okay, so let's go ahead and plug both sides into an exponential. So both of these are now the exponent. So e to the natural log of y, that's just y. Okay, so let me get rid of that. We have a y equals, and now I have e to some number, 1.38629 plus 2 natural log of x. All right, but now rules of exponents are very similar to rules of logarithms. I can break up an addition in the exponent to be multiplication outside of the exponent. So 1.38629 times e to the, and now even though we're used to writing 2 times natural log x, well actually, you know what, let's just use that power rule of natural logs in reverse. So now I have natural log of x squared. And again, natural log and e, they cancel. And so what's really going on is that this term is just an x squared. And now notice what we have. We have a formula that looks like c x squared. Okay, so this m and this b, okay, here they are. If I start to apply the exponential, it's trying to tell me what my power and my y-intercept are, or sorry, this constant c is. And if I wanted to find out what that is, so I could ask Desmos, I could say, hey, what is e to the b? Oh, it's 4. 4 was the mystery thing here. I actually had 4x squared as my function, which we knew that because that's what I had programmed it in as right here. But so hopefully you're seeing how all this is related. And just to show you some other things, so it really does, if I made this the 5th power, right, then notice the y-intercept of my line, so watch that blue line. It doesn't change the y-intercept. It just changes its steepness as I do that. Whereas if I change this 4 to like a 1 or make it a 10, that's changing the y-intercept, but it's not changing the slope. Okay? So anyway, I hope this helps you in figuring out problem 4. Let's go ahead and stop the video there, and I'll make another one for problem 5.